Hello, ladies and gentlemen. We are going to start dilating shapes properly now. Dilations are a very simple transformation to perform because they're as easy as just multiplying everything you see by a scale factor, by a simple number. But before we dive into that, I want to make a clear distinction. Up to this point, translations, reflections, and rotations, they are what we call rigid transformations. Rigid transformations are when you move a shape, but you don't change a shape. You might change its rotation, or you might change its orientation. It might get flipped, it might get moved to a different location, but you're not going to change the shape itself. It's going to stay the same size, it's going to have the same angles. Nothing about the shape itself is going to change. With dilations, that is not the case. With a dilation, the pre-image and our new shape, our image, are going to be two different shapes. They're going to look the same, but one's going to be bigger and one's going to be smaller. And that makes dilations in a completely different class than rigid transformations. Now, dilations, as I said, are actually a very simple transformation to perform. All you need are the points of your shape, which we have here, and a scale factor, which we have right here. The way you dilate a shape is simply by multiplying each point by the scale factor. So if I were to write a key, the key would look something like this. It would be x comma y, and make this change to it. Since our scale factor is 2, we're going to multiply 2 times our x and 2 times our y. So let's try it out. Let's see what that looks like in practice. For a prime, that simply means multiplying negative 2 times 2, which is negative 4, and 4 times 2, which is 8. For b prime, that would mean just going 2 times 2, which is 4, and 4 times 2, which is 8. And there you go. It's dilated. Let's graph the points. Negative 4, 8 would be right here. And 4, 8 would be right here. This is A prime, B prime, and now a little line to connect them. That's a bad line. Let's try that again. Let's cheat a little bit. Here we go. That's a much better line. There you have it, guys. That is a dilation. Now, before we move on to the next one, I want to try a little thought experiment out. Why don't you guess? Yes, A prime, B prime is bigger than A, B. But how much bigger? Is it 2 times as big? 3 times as big? 4 times as big? I want you to guess and use this scale factor to inform your guess. And now let's count. A prime is A to B is just 4 units long. A to B prime, or A prime to B prime, is 8 units long. So A prime to B prime was twice as big as A to B. And that makes sense, considering we multiplied everything by 2. Twice as big. Really, the point I want to get across is this. When you're using a scale factor, you can already kind of infer what the new shape might look like based on the number you get. If your scale factor is bigger than 1, you're going to have a larger shape. If your scale factor is less than 1, well, let's find out what happens. I have a new line here. This line is still AB, but it has different points. We're going to dilate it using the scale factor k equals 1/2. So what would that look like? Well, that would look like this. Starting with xy and making this change to it. We're going to multiply x by 1/2, and we're going to multiply y by 1/2. Now this is going to mean we're going to multiply a fraction by a whole number, because if you look here, all my numbers are whole numbers. But if you watched the last video, that's going to be a breeze. So let's try it out. A to A prime, negative 8 times 1/2 would just be negative 8 over 2. Well, negative 2 times 1/2 would just be negative 2 over 2. And of course, these can be simplified, so we'll say it one more time. A prime equals negative 4 and negative 1. There we go. I'm just simplifying the fractions. Excellent. How about B prime? B prime is going to look very much the same in that it'll be negative 2 over 2 and negative 2 over 2. So in other words, B prime simplified is just negative 1 over negative 1 comma negative 1. There you go. Now let's graph it. Negative 4, 1 is here. That's A prime. Negative 1 is here. That's B prime. Let's see if I can do a small straight line. That's close enough. Excellent. And notice, it shouldn't be too shocking here, but notice that when our scale factor was less than 1, did our shape get bigger or smaller? It got smaller. Very good. All in all, why is it important to know if my shape's going to get bigger or smaller? It's really just to double check our answers. If I multiplied by 1/2 and then I got a shape that was bigger than my original, I would know something was wrong. I would know something right off the bat, something is wrong. So if we can keep that in our mind, it might help us from making little itty-bitty mistakes. Maybe I flipped the fraction, or maybe I didn't divide. In any case, the long and skinny of it, yeah, that's the expression. The long and skinny of it is this. To dilate a shape, simply multiply the numbers by the scale factor. If you're multiplying by a fraction, you will have to simplify. Well, most likely have to simplify. But at the end of the day, it's just about multiplication. In the next video, we're going to do a couple of practice problems, and my hope is that you'll practice along and master it by the end. All right, I'll see you there.